Next, we look at the approach, how the cutter approach the wall. And okay, let's go navigator. Okay, you can see that this is the last pass. Okay, so locate the cutter here and let's look and see how the cutter approach the wall. It approached by 90 degree. Okay, so if this is the first layer, the cutter contact between the cutter and the wall is not so deep. Okay, if you go in 90 degree, that is still okay. But if you look at the last layer, let's go by layer. Go look at the last layer. This is the last layer. And move the tool, come here, and let's off the PMI and simulate. You can see also a normal approach. So at the last area, the cutter contact to the wall now is almost 10 mm. So the contact is increasing. This also means that the load is also increasing. Okay, so if your cutter is too long or not stable, you tend to vibrate and give you marking here, and this is not a good result. To solve this problem, you can always edit the pocket again. We can always use this approach options. Yeah, now it's normal. We're not going to use normal. We'll use the tangents. Okay, with a radius. For the compensation line, because we are not using C023, you can ignore this. So radius of 10 is okay in this case. Then let's calculate, right? And let me simulate again. Navigator, go to the last layer. Go to the last layer. Oops. Yeah, this one here. And I'll move the tool to here. Let's look at how the tool will move at the last round. Okay, you will move by tangent in to the wall. Okay, and this will ensure a smooth entry, and also when the machine out, it will tangent out from the wall. You also ensure a safe exit, good exit. Okay. Okay, let's look at this pocket process again. We know that at the Z bottom we cut until -9, so that we can remain 1 mm material on top of this face, so that we can do a finishing operation on this face here of the face of the island. How about the side? Okay, so I'm going to check the remaining stock for this part. You can check by selecting the pocket and right click and select the remaining stock, and you can click on this to show the remaining stock, and you can take out the SQC. You can see here, okay, up to now so far we haven't put an offset, okay, near the wall for the finishing process, right? There's zero offset, no offset at all. Okay, so we have to put a offset at the wall, so that later on we'll use a finishing cutter to cut again the wall to the exact size. you need to go to the motion parameter. It is under the boundary setting here, contour offset again. So here I'm gonna put the 1 mm offset to offset the material, right? And calculate. Let me use a navigator show you the last parts. Looking from top, you can see now. After I put 1 mm offset, I have a 1 mm remaining material over here. This is for finishing. Finishing cutter to machine this, right? And let's check for remaining stock again. You can see now this is the edge, and we have 1 mm material remaining offset from the contour. This is for the finishing profile to cut. Okay. Let's simulate this pocket. Simulations and G54. The rest is okay. And you can click play. Look at the helix entry. Okay, now look at this here. Now, currently the tool is cutting at a depth of -9. So when the tool roughing at the center, you can see the tool is still cutting a material of a down step 3 mm and a side step of 4 mm. Okay, the load is still 3/4, right? But if we wait, okay, if we wait until the last layer where it cut the wall, you see here, it is cutting the wall, right? And you can see here, right? When the cutter cutting at this depth -9 and at the last pass, the cutter touch the wall, that means the contact is -9. With the minus 9 mm contact and a side step of 4 mm, the tool load is very high at the last pass of these machines. So the tool will tend to vibrate if you have a long tool. Yeah. So how to solve this load problems? Let's close the simulator. And to solve this, we can set these parameters here. You see the boundary offset is for you to key in an offset for finishing. How about the contour offset for under the tolerance and the offset? Okay, contour offset means that, okay, I can specify, okay, during roughing how many mm I want to remain at each layer. Okay, so I'm going to put a contour offset of 1 mm, right? And over here we have a mill finish pass. So I'll on this. If you on this, there's one parameter automatic will be on, mill outer contour. This one also make sure you check yes. And let's see what happened. Okay, let's go and simulate again. Now please notice the last round, okay, when cutter touch the wall, how many mm the cutter cut actually. Okay, so now it's not yet. Okay, so after roughing each layer, C023 will leave 1 mm of material for the finishing pass to cut. Let's again, you see here. Now the cutter, instead of cutting 4 mm side step, at the last, when the cutter touch the wall, it only cut the 1 mm. That is the contour offset rough. Okay, so each layer you rough first, and leave 1 mm material behind at the wall, and then you create another finished pass to cut away the 1 mm. Okay, look closely. Okay, here you see it cut and leave 1 mm at the wall. This is contour offset rough. Right? The purpose is to avoid the cutter contact the wall during roughing. Okay, so after roughing process finish, it will go and cut again the 1 mm. Yeah. Now it's cutting the 1 mm of material. Okay, so although the contact is 9 mm, but it only cut 1 mm side step, 1 mm material, the tool load is greatly reduced. So this strategy is good for long tool and small tools. Yeah, this is called mill finish pass. Okay, mill finish pass will generate a finish pass at the last of each layer. Let's stop. So if you look closely here also, we use a navigator. Let's go by layer. Do you see each layer? Yeah. Each layer, the roughing will leave behind 1 mm of material. After roughing, it will create a finishing. Okay, cut away the contour offset rough, the 1 mm materials. Right. That's why you see a double line here. This is 1 mm.